Hi, this is Jeff from the Ozark Mountains in Missouri, USA. We're doing kind of a hybrid episode today. It's a Ferengi Friday with the twist. We only have one item, and we're going to try to repair it at the same time. I got this package in the mail, and it was addressed to a Ferengi Friday program, which I thought was kind of interesting. This is from my friend Chris. I've accused him of being a bad influence on me, but that's all in good fun. He found this, and he says that it will turn on with the reset button, but not the on button. So we're going to see if we can fix it. First, I'll get it out of the box, and we'll take a look at it and see what it is. Try it out. Let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. Wow, this came in the box and everything, and it's obviously a Japanese market. Sharp PC G820. Box is in nice shape. Sounds like it has some plastic internal packaging. Oh, it's got a manual in here too. So it's got a nice cover on it, just a tiny bit. It looks like in good shape. Little scuff there on the cover. Maybe somebody was looking for a screw. And it's got the manual, which is in Japanese, of course. Okay. Let's have a look at the unit and verify the problem. So I took the battery cover off, noticed it did actually have what looked to be new batteries in it, along with this label here in Japanese, which seemed to be related to replacing the batteries. So I ran that through Google Image Translate. I'll pop it up here on the screen. So it says to turn it off, replace the batteries, make sure they're in the right way, turn it on, and then press reset, and then yes to the reset. It wasn't even coming on though, and I noticed that these batteries are all about 1.2 volts. So that makes me suspect that there's an issue with, since it's not turning on right, that it's also not turning off right, or something's, something's amiss and ran the battery down. So I put new cells in it here, and it came on. So I'm going to press reset, hold that down for about 5 seconds. Memory clear, yes. Okay, clear the screen. Does this have a contrast? It does have a contrast knob. Okay. I got the contrast set up a little high so it'll look okay on video. That way I can see it too. Okay. All the buttons seem to work okay. And we can turn it off. And if we try to turn it back on, not a sausage. But if we press reset, it comes right back up. Okay. Well, that's just like my buddy said. So we'll take those batteries back out and have a peek. So we've got this nifty little deal here. Okay, so we got all the other batteries sorted out. I think we'll need to take this system bus cover off somehow. Ah, like that. I thought it was this whole thing here, but it's just that. That kind of covers the brake. All right, and I'm going to put down a rag here to keep from scratching up the front bezel. Looks like we got 2 screws, about 10 millimeters long, maybe 2.5 millimeters in diameter. All right, and I think maybe these 2. Okay, those are the same. So we got 4 identical screws. That always makes things easier. And we'll get a spudger here. There we go. Oh, there was room for a speaker in there, and that's sticky still. Little shielding. And my buddy also sent me a link to a page that tells you how to swap out the 8K RAM for a 32K RAM. You notice there's a spot here. Maybe that's for another ROM. They tended to use the same boards for different models and different, there were models that had more functionality, so they'd have a different ROM or maybe an additional ROM. These are probably LCD drivers. They're Hitachi HD 61203, 61202. And this is probably the processor here, a Sharp LZ 8413AM. Gotta get the old man glasses now. The power supply here, DC to DC converter, contrast knob. Battery connection here and here. So that's weird. This area, it looks like it had some things cut out by hand. Somebody did a rather rough job trying to get into it. Yeah, it's got a catch broken off here. And here, and here. Okay, I think I need a smaller screwdriver. And okay, there's 2.5 millimeter, maybe 3 to 4 millimeter. And we've got a few other. These are the same size screws through the board proper. Okay. Ah, one more screw there. It's interesting, that almost looks like a spot for a buzzer too. But there's room for something there, and it goes over to this side of the board, which is strange. So we have to do some research to see if we can put a buzzer in this thing. And I don't see any other screws. Okay. Got that loose. That loose. If we rotate this over, well, I gotta turn this upside down to see which one's the on button. The on button is right here. And of course I knocked a bunch of keys out of place. Having the rag under here does cause problems with the keys. And there my air conditioner came on. And there is the on button and off button and reset button. Don't see any signs of corrosion. Okay, see if we can get those batteries to stay in there. It did come up. Turn it off, okay. Turn it on and it doesn't do anything. what the reset does. I don't know which key is the Y key off the top of my head. Maybe I can do this. Oh, that still doesn't show me. Oh, silly me. Okay, there's off. Different pad for on, and that's not doing anything. Okay. Let me fix these buttons here. I could not find a schematic for this PCG 820. Looking up the processor number, the LZ8413AM, come up with a PDF for a Sharp PCE220, which is basically the fancier version of the same pocket computer. It just has more features. So that's been a big help. I'll pop it up here on the screen. We have the 6 volts coming in. I've got it connected to the bench power supply here. And if we look, we have about 5.2 volts. That's, we run through one diode drop, so in a current limiting resistor, so that's fine. In this area of the board, we have a DC to DC converter for the negative rails of the LCD. So we have our 5.2 volts there, and output, wrong leg, there, output there, minus 8.2 volts. That's fine. So the next thing I did was, I flipped the board over and I put my meter in continuity mode with the beeper on, and I traced back where the on button went, and it went directly to the processor, which makes sense. That's typically how these things are wired, and you can see here on the schematic that the on button, the reset button, and the shift button all go directly to the processor. That way the processor can be off, in a low power mode, and the on button or the reset button can act as interrupts and turn it back on. So I soldered this wire to it. That way I could press the on button and watch the voltage going into the processor and see that, yes, indeed, the button does work and it's getting all the way back to the processor, and measure it at the right pin and all that sort of thing. And then I found an easier way to test the on button. Let me see if I can get this flipped around here without causing problems. Okay, the easiest way to check if the on key is actually getting the signal to the processor is press reset, get to this memory clear, then press Y. And you'll get this all reset flashing, and instead of pressing the clear screen button up here, press on, and it clears the screen. So we know without soldering wires or tracing circuits that the on button is getting to the rest of the machine. The next thing I did was check power usage. Let me set up for that, and I'll show you how that works. Okay, here I've got the meter in line with the positive of the power supply, and we're reset, we're in run mode, we're not doing anything, we're at idle. And it's drawing 13 milliamps, 13.2 something, and that seemed very, very high to me. This is maybe twice what it should be. And fortunately in the manual they list this, and they say at idle this should be about 7 milliamps, and off it should be about 1/4 of a milliamp. So if we turn this off, you can see it's almost 9 milliamps. That is way too high. So that's why the AA batteries that were in it when we got it were flat, because this thing is drawing like, what, 32 times the power that it should. So something's wrong here, and it left me scratching my head a lot. I was still confused why on wasn't working, and there's a signal that goes from the processor here up to turn the DC to DC converter on or off. There's other signals that go to the LCD drivers for the same thing to enable them. But all this seems to work in reset mode. So I checked to make sure that when power was off, that our DC to DC converter is off, and it is. We don't see anything on the LCD. We don't have power here. So it's probably not our LCD drivers. they've got nothing to drive, so, you know, with the no power coming into them. And then I noticed that this black part right here is a low voltage reset. And it describes in the manual how it works and how they use it to detect low voltage and then to shut the processor off. And if the voltage is low enough, it won't even let it turn on. Reset won't even work. So that didn't seem like a problem, but I checked it by setting the bench power supply to different voltages, and it does indeed seem to work fine. When testing that, though, I noticed that even when it's off, after I press the off button with the keypad, the clock is still running. That should be happening. In an off mode, it should not run the clock. That takes a lot of power. And then it seems like, oh, maybe the processor is not actually shutting off, so it can never get to the state where it can turn on again. But reset, which is supposed to reset you from, you know, an unknown condition and completely, you know, reconfigure everything inside the processor, all the registers and such. But reset then works. So that's making a little more sense. Unfortunately, this is a custom processor. It is based on a Z80, but it's got all the special stuff to do with the pocket computer. It's only used on a few models of Sharps. This is the only one that I have, so I can't swap the processor from anything else. You know, LCD driver chips, I don't have any of those. The ROM chip is special. So, you know, if it's any of these 4 chips, I don't have those. I can't do anything about it. And then I got to wondering, well, what could be wrong with the RAM that would cause this symptom? And initially I thought, oh, nothing. And I slept on it. And I thought, well, what if when the processor's reset, it's setting up some jump vectors here in RAM that are used for things like turning off. So it's doing the initial part of the off routine. It shuts off the DC to DC converter. It disables the LCD drivers. And then it tries to jump to this location, which is garbage. It's a bad location in RAM. And so the processor never shuts off. And, you know, maybe the extra current draws because the RAM is bad and it's doing something internally that's silly. I don't think that's the case. I think it's a very slim chance that that's the case. I do happen to have some of these chips that I know are good. It won't take long to swap out. So kind of a Hail Mary play here. I'm going to go ahead and swap out the RAM chip and we'll just see if that takes care of it. If that doesn't, then I'm pretty sure it's going to be the processor, which I don't have. All right, I got the RAM swapped out. I even reflowed the processor just to be safe. You can see we're in idle, still drawing 13 milliamps. If I turn it off, still drawing almost 9 milliamps. So still something wrong. Another test for the on button you can do, I forgot to show you before, is just press it, watch the current draw. See, it'll go up about 1 milliamp when you're pressing the on button. So yeah, it wasn't the RAM chip. It wasn't a cold solder joint on the processor. I'm guessing it needs a new processor. Don't have one. So this wasn't successful, but sure learned a lot about how this thing works. Well, I thought I was done, but I decided to try a couple more things. I pulled the low voltage reset, the little black thing you see here, and tied that to VCC with a 10K resistor. Didn't make any difference. So then I lifted the VCC pin from the processor very carefully. I soldered in some jumper wires, measured the current going through the processor. Even when in off mode, it is almost 6 milliamps. And then I noticed that the address and data bus and everything's still working. The processor is continuing to process. All it seems to do is shut off the LCD and everything else keeps running. Well, that wasn't successful. I didn't successfully channel ROM, and we weren't able to do a Ferengi fix on this broken Sharp PCG820. Sure did learn a lot about how it runs and that it's related to the PCE220. I'll do some research and see if there's any other machines that use this particular version of this processor. You might be able to hear it thundering outside. My cat's going to be panicking and running all around, trying to hide somewhere. At any rate, I'll get this put back together. I guess we'll save this particular machine for parts. Hopefully you'll be able to use it to fix another machine or find a processor that'll go into it. If you happen to know if these sharp processors are used in other pocket computers other than these two, let me know. I would appreciate it. Yeah, that's kind of how it is, right? You're not always successful in a repair, but it's a lot of fun trying. You learn a lot in the process, and maybe learn some new skills along the way too. So if you have any questions or comments, let me know. Love to hear from you. Just leave them in the comment section down below. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means, like donating the stuff that needs fixed. And until next time, bye.